Hel- Hello, good morning, students. I am Dr. Sunita Tandon from RR College, Alwar. Today, I am going to complete the reaction BZ reaction, which we have started earlier. In the lecture number 8, I have started Belazov-Zobeninsky reaction. In that reaction, we have seen the reaction is very complicated reaction, which remains unexploited for a longer period so far as its mechanical steps are concerned. In 1959, Belozov introduced the cerium 3 catalyzed oxidation of malonic acid, which is represented by HMA, by bromate ions BRO3 ions in sulfuric acid mixture. Later in 1968, Zobtensky showed that if the reaction mixture left unstirred, spatial periodic variation of intermediate can also occur. Spatial means SPATIL. Spatial means in space, in 3 dimensions. He determined that instead of cerium 3, weak equal reductants like MnO2 and iron 3 can also be used. This reaction is called as BZ reaction and can easily be represented by 2 bromate ions combined with 2 H ions in presence of 3 malonic acid molecules. Malonic acid is CH2, then COH, dibasic acid, and then cerium 3 and bromate ion की presence में it will give 2BrCH COOH. CH जो group है that is converted into carbon dioxide and water, and one COOH group, one CH from one CH to H is removed. Or we can write 3 bromate ions plus 3 H ions plus 5 molecules of malonic acid. They give cerium and bromide ion 3BrCHCO2 plus 4CO2 plus water plus 1 HCOOH formic acid. With this we have started the reaction, and then we have seen the different sequences in which reaction can take place. Out of which sequence 1, which show contains sufficient amount of bromide, the reduction of bromate and bromination of malonic acid by HRO3 occurs by different methods. Similarly, in sequence B, cerium 3 is changed in cerium 4. Bromide ions fall below its critical value. So the reaction between bromate and HBRO2 becomes more faster than between HBRO2 and bromine. This is sequence number 3. Now we will study the sequence number C, sequence 3 or sequence 3rd. When enough cerium ion, cerium 4, is produced by reaction B, then in oxidation of BrCHCO whole twice by cerium 3 starts. Next है BrCHCOOH whole twice combines with 4 cerium ions and 2 water molecules with rate constant of KH, A8 to form bromide ion and HCOOH plus 2 CO2 plus 4 cerium 3 ions and 5 hydrogen. Next step is HOBr reacts with HCOOH, which is formed in the former step with rate constant of 39, and it is a fast reaction and forms bromide plus CO2 plus H ion plus water. Next reaction is reaction number 9 and reaction number 8. And we can write BrCHCOO whole twice plus 4 cerium ions plus HOBr plus H2O. They will be raised 2Br plus 3 CO2 plus 4 cerium plus 6 H. This is equation sequence number C. Overall, the form of BZ reaction for oxidation of malonic acid is obtained by adding reaction of sequence A, sequence B, and sequence C as follows: 2 bromate ions plus 3 malonic acid molecules plus 2 H ions in presence of cerium 3 and bromide ion. They form 2BrCHCOOH whole twice plus 3 CO2 plus water. Concentration of bromide and cerium 3 are indicating that these species play a true catalytic role. Kinetics of BZ reaction. A brief kinetic analysis is as follows. Assuming steady state for concentration of intermediate HbRO2 and BrO2 species, we can write d by dt of HbRO2 is equal to 0. Rate of formation is rate of removal. D by dt of BrO2 is equal to 0. This is equation 1 and 2. And in the third reaction, these two are equal. So d by dt of HbRO2 is equal to d by dt of BrO2. And apply steady state rule to HbRO2 species. अब HbRO2 पे अप्लाई करेंगे, फिर BrO2 पे. तो HbRO2 इसमें आप देखिए कि HbRO2 कौन कौन से स्टेप में बन रहा है और कौन कौन से स्टेप के अंदर रिमूव हो रहा है. तो HbRO2 का पीछे से केमिकल काइनेटिक्स की जो इक्वेशन लिखी है उसमें हम देखें तो d by dt ऑफ HbRO2 ये K1 स्टेप में बन रहा है एंड K1 इज इक्वल एंड रेट इज इक्वल टू K1 H आयन स्क्वायर प्लस ब्रोमेट आयंस इंटू ब्रोमाइड आयंस माइनस इन सेकेंड स्टेप इट इज रिमूविंग K2 आयंस इंटू H आयंस इंटू HbRO2 आयंस and this is minus next minus K5 into concentration of H ions, concentration of bromate ions into concentration of HrBO2 plus 6 में it is also forming K6 into H ion plus BrO2 into cerium 3 ions minus 2K7 into HbRO2 whole square is equal to 0. Apply steady state rule to BrO2 species. D by dt of BrO2. It is forming in step 5. So 2K5 H ion, BrO3 ion and HbRO2 concentration minus K6 into H ion concentration into BrO2 concentration into cerium 3 concentration is equal to 0. Or K6 H ion concentration, BrO2 concentration, cerium 3 concentration is equal to 2K5 H ion concentration, BrO3 ion concentration and HbRO2. From equation 1 and 2, we get that K1 into concentration of H ion square, BrO3 concentration, Br ion concentration minus K2 into H ion concentration into HbRO2 concentration into negative concentration minus K5 into H ion concentration into BrO3 ion concentration into HbRO4 plus 2K5 H ion concentration into BrO3 negative concentration HbRO2 minus 2 into K7 into HbRO2 concentration का square is equal to 0. Or we can write H ion K1 into H ion concentration का square, BrO3 negative का square, Br negative concentration, Br negative, Br केवल bromide and radical concentration minus K2 into H ion concentration into HbRO2 concentration into Br free radical concentration plus K5 into H ion concentration, BrO3 concentration, radical concentration, ion concentration, HbRO2 concentration minus 2K7 into HbRO2 raised to power is equal to 0. This is equation number 3. In equation number 3, two limiting situations are possible. कौन सी? When Br concentration is greater than HbRO2 concentration. ठीक है, when for equation 3 two limiting situations are possible. ठीक है, कौन सी है इक्वेशन 3 हमने लास्ट में देखी. इसमें Br कंसनट्रेशन जो है वो बहुत ज़्यादा हो HbRO2 कंसनट्रेशन से. देन निग्लेक्ट लास्ट टर्म ऑफ इक्वेशन 3. इक्वेशन 3 की लास्ट टर्म को आप इग्नोर कर सकते हो. तो वी कैन राइट K1 इंटू H आयन कंसनट्रेशन का स्क्वायर, BrO3 नेगेटिव, Br नेगेटिव माइनस K2 इंटू H आयन कंसनट्रेशन इंटू HbRO2 कंसनट्रेशन इंटू Br आयन ब्रोमाइड आयन कंसनट्रेशन प्लस K5 इंटू H आयन कंसनट्रेशन, BrO3 ion concentration, HbRO2 concentration. This step K7 is 0. K1 into H ion concentration, BrO3 concentration into Br concentration is equal to K2 into H ion concentration into HbRO2 concentration into Br negative ion concentration minus K5 into H ion concentration BrO3 ion concentration upon HbRO2 concentration. ठीक है, दिस विल गिव यू एच आयन कंसनट्रेशन हमने इसमें कैलकुलेट करने की कोशिश की है, बट दिस इक्वेशन गिव्स K1 इंटू एच आयन कंसनट्रेशन का स्क्वायर BrO3 कंसनट्रेशन इंटू ब्रोमीन कंसनट्रेशन. दिस इज इक्वल टू K2 इंटू BrO2 इंटू Br माइनस K5 इंटू BrO3 इंटू HbOr. ठीक है, एच आयन इन्होंने बाहर निकाल लिया. Now K1 into H ion concentration into bromate ion concentration into bromide ion concentration is equal to HbRO2 into K2 into Br concentration minus K5 upon BrO3 concentration. So from this we can calculate the concentration of HbRO2. This comes out to be K1 ion concentration into H ion concentration into BrO3 concentration into Br negative concentration divided by K2 into Br concentration minus K5 into BrO3 concentration. When Br concentration is much less than HbRO2 concentration, then in equation 3, first term and second term can be neglected. Third term and first term and second terms can be neglected. Since Br ion is too small to deplete the HbRO. So we can write K5 H ion concentration into BrO3 concentration minus K7 into HbRO2 concentration. The whole square is equal to 0. Now 2K7 into HbRO2 whole minus square is equal to K5 into H ion into BrO3 into HbRO2. HbRO2 से एक HbRO कट गया. Now 2K1 is equal to HbRO2 is equal to K5 into H into BrO3. Now HbRO2 concentration is equal to K5 into H ion concentration into BrO3 concentration upon 2K7. For the concentration of HbRO2SS and HbRO2, the system is non-stationary. That is, it may switch back and forth and between the two steady state conditions. ठीक है, दो कंडीशंस हैं स्टेडी स्टेट की, दोनों में से कहीं भी स्विच कर सकता है. Another term for such a switching behavior is disability. If initially the concentration of Br is small, the reaction cycle is shut off. Serous ion is oxidized to ceric ion and the reaction cycle proceed to generate bromide ion Br negative. As concentration of bromide ion builds up, reaction cycle turn back on. Cerium 4 is no longer produced and bromide ion is consumed. The concentration of these species may oscillate back and forth between these two steady states. The significance of this reaction is in the living body system and hence help in understanding biological oscillations, beating of heartbeat and pulse, biological evolution. So we have seen that how does BZ reaction is important to us, and next we will study in the next chapter, lecture number 10. This is lecture number 9. ठीक है, thank you student. If you have any queries you can ask me on my channel. Thanks.